Okay, set 3 in linear relationships. We're going to do some graphing linear relationships today. So let's have a look at this little rule here we've got. Output equals input plus 3. Now, we're just looking at number patterns. So we can make a number pattern where any number we put in, so that's our input, and then we add on 3, gives us the number that comes out. So that's our output. So as an example, let's say we put in the number 10. 10 would be our input. We add 3 to it and we get an output. What comes out is the number 13. Okay. If I was to put in the number 25, put in the number 25, that's my input because that's what I'm putting in. I add on 3 and I get the number 28. That's my output. Okay. If I was to put in the number 0, that's my input. Add on 3 and I get an output of 3. Okay, so we're making a pattern where whatever number we put in, we add 3 to it, and that's going to be the number that comes out. Okay, so the relationship between input and output is always going to be this difference of 3. We add 3 onto our input, we get our output. Okay, so let's have a look at this table of values. And let's apply the same rule that we just looked at. So our rule was our output is equal to our input plus 3. Okay, so whatever our input is, we add on 3 and we get our output. So our input is 1, let's add on 3, we get 4. Our input is 2, let's add on 3, we get 5. Our input is 3, let's add on 3, we get 6. If our input is 4, we add on 3 and we get 7. So you can see there's a pattern happening. 5, 6, 7. I'm sure you can predict that the next number is 8, 9, 10, etc. Okay, so whatever the input is, the output is always 3 more than it. Okay, so we can also have a look at this pattern in terms of a graph and what it would look like if we were to graph it. So what I mean by that is we can plot the points. Let's call our input x and our output y. So what that means is when x is 1, y is 4. So we plot that by going when x is 1, y is 4. And we put a dot. When x is 2, y is 5. So when x is 2, y is 5, we put a dot. When x is 3, y is 6. So x is 3, y is 6, put a dot. And the last one, when x is 4, y is 7. 4 and up 7, put a dot. So you can see not only does it make a nice pattern here in our table, it also makes a pattern when we graph it. Now this topic is called linear relationships for a reason, because everything we end up graphing is going to be a straight line. Okay, if one of these points wasn't in line with the others, you'll know that you've done something wrong and you'll need to have a look at it. So now I can just join these points up with a nice straight ruler, of course. I know that's a terribly not straight line. Okay, there's my line. It makes a lovely straight line. And that's my relationship, because anywhere along this line, you'll find that the y value is 3 more than the x value. Okay, for instance, if I was to pick this point here. Now this point is x is minus 1, y is 2. So you'll see, if you take this first number, the x value, and add on 3, you get the second number. Okay, let's take this point here. X is minus 5, y is minus 2. If you take this first number and add on 3, you get the second number. Okay, so now we've got a table here. Now this is the exact same rule we've just been dealing with, except instead of the words input and output, we've now got x and y. Okay, so y is equal to whatever x is plus 3. So whatever x is, we're just going to add 3 to each of those numbers. So 0 plus 3 gives me 3. 1 plus 3 gives me 4. 2 plus 3 gives me 5. And 3 plus 3 gives me 6. Okay, so exactly the same numbers as we were dealing with before, because we're just adding 3 to each of them. And then we need to graph it, and you'll find that's the graph that I just drew there. Okay, let's move along and do the next question. Now here's my rule. My rule this time is we're going to take the number x, whatever x is, times it by 2, and then take away 3. Okay, so my rule, times by 2 and then take away 3. Okay, so we're going to start off with 0. 0 times 2 is 0. Take away 3 is minus 3. All right, let's do 1 now. So 1 times 2 is 2. Take off 3 gives me minus 1. 2. 2 times 2 is 4. Take away 3 gives me 1. And then 3. 3 times 2 is 6. Take away 3 is 3. Okay, we're going to graph this on our Cartesian plane. So have a look at each of these coordinates. When x is 0, y is minus 3. So when x is 0, y is minus 3. When x is 1, y is minus 1. When x is 1, we go down to where y is minus 1. Put a dot. Now bear in mind these dots should form a straight line. Okay? When x is 2, y is 1. So when x is 2, we go up to where y is 1. When x is 3, y is 3. X is 3, y is 3. And here is our line. And if you join them up nice and neatly, you should get a line that looks like that. It's not that easy drawing on my computer, but there you go. So this here is the graph y equals 2x take away 3. Okay, makes a pattern here. We're going up by 2's, and makes a pattern here because it's making a nice straight line. Not at all one bit wobbly like mine may appear in the picture. Okay, here's our next rule. We're going to, this time, take our x value, times it by minus 2, so times by minus 2, and then add 1 plus 1. Okay, so let's start off with 0. So 0 times minus 2, 0, because anything times 0 is 0. And then we're going to add on 1, so that gives me just a positive 1. Okay, then we've got 1 times minus 2 is minus 2 plus 1 gives me minus 1. 2 times minus 2 is minus 4 plus 1 is minus 3. 3 times minus 2 is minus 6 plus 1 is minus 5. Okay, so now we've got our coordinates. We can plot these onto our graph. So when x is 0, y is 1. So we go across 0, which is nothing at all, and then up 1, and we put a dot, and there's our first point. When x is 1, y is minus 1. So x is 1, y is minus 1, put a dot. All right, when x is 2, y is minus 3. So x is 2, we go down to minus 3, put a dot. When x is 3, y is minus 5. So x is 3, down to y is minus 5. Put a dot, and you'll see that these make a lovely straight line. And I can draw a lovely straight line on my computer so beautifully. All right, and it looks like that. Now you notice I do put arrows at each end. That just suggests that the line goes on forever. Okay, so our last example says that we're going to have a look at the point 1, 3, and we're going to show that it lies on this line. Now, to show that it lies on that line, there's a couple of different ways you can do this. What I'm going to do is I'm going to draw a table of values like we did before. I'm going to draw the line, and then I'm going to show you that the point lies on the line. Okay, so you need a table of values. So if you have a look at the one just like what we did, we're going to draw up a table that looks just like this, okay? We're going to start with x at 0, and then 1, 2, and 3. Okay, so y is going to be, now here's our rule. Y is equal to whatever x is, times 4 and take away 1, okay? So our rule is times 4 and then minus 1. Okay, so I'm going to take each of these numbers. So let's start with 0. 0 times 4 is 0. Take away 1 is minus 1. All right, now we're going to do number 1. So take the number 1. times it by 4, we get 4. Take off 1, we get 3. Now we're going to do the number 2. 2 times 4 is 8. Take off 1 is 7. And finally the number 3. So 3 times 4 is 12. Take away 1 gives me 11. Now we're all about patterns. So what pattern do you notice? What are these all going up by? They're adding on 4 each time. Okay, and you should notice the reason they're adding on 4 each time is because that's the number we're multiplying by. We're multiplying by 4, hence they're going up by 4. All right, let's plot this. So when x is 0, y is minus 1. X is 0, y is minus 1. When x is 1, y is 3. X is 1, y is 3. Put it up. X is 2, y is 7. X is 2, y is 7. And my last point is going to be off the graph. It's going to be up here. So I'm not going to plot that one, but that's okay because I can join up these lines here. All right, so there's my line. It looks like so. All right. Now, the question says, show that this point, 1, 3, lies on the line. Well, you can see now, go across 1 and up 3, and there's that point there. It lies on the line. And the reason it lies on the line is because it's actually in the table here. So here it is here in the table. When x is 1, y is 3. Now the shortcut to showing that this point lies on the line is actually subbing in this number 1, because this is my x value, putting this x value into here where the x is, and checking, do I get what the y value is? Now the y value is 3. So here's your shortcut. Without doing any of this graphing, you can tell if it lies on the line. So I'll get rid of all of that and I'll show you how. Okay, we're going to take the x value. We're going to put it into our rule. So the number 1. Remember our rule was times 4 and then take away 1. So 1 times 4, take away 1. 1 times 4 gives me 4. Take away 1 gives me 3. And 3, you'll see, is the y value. So because when I put in the x value into my formula, I got this y value, that means that it lies on the line. So your answer is yes, it does lie on the line, because when I substitute it in to this equation, okay, I'll get 3 because y is equal to 3. 3 is equal to 4 times x, so 4 times 1, take away 1. Because 4 times 1 is 4, take away 1 equals 3. And that's how I can show it. Now, I don't expect you guys to do it like that. I think the best way for you now is to practice doing your table of values and plotting the points, and you can go, oh, yep, 1, 3, there it is. It's on the line because my line was going like so.